start at either n equals 0 or 1. We're never going to have a negative, never going to have n equals a negative number to worry about that. Right, so from this standpoint, but going back to last chapter, right, if you're integrating from negative infinity to infinity, right, sometimes we went from like negative infinity to 0 and then 0 to that, right? And if one of them diverged, then the whole thing diverged. Right, that was one of our notes. We wrote that down from that. So that's not going to impact here with the integral test, because again, the series is only going to be positive and 0 or positive n values that we'll be starting from. Okay? All right, so what we got here is another test, right, that we can use that if you can integrate it, right, if you basically look at this series and go, oh, right, I know how to integrate that. I can find its antiderivative. Then just go ahead and find its antiderivative, right? And if the antiderivative converges, then the series converges, right? If the antiderivative diverges, then the series diverges. Okay? All right, so it's another great way to look at it. Okay? So again, you're going to get, a lot of times there's multiple ways to justify an answer. There's not always just this one test that's going to, work, right? There's a lot of different tests that might work and that you could use. Okay, so you gotta kind of figure out, what do I use when, what do I do? Okay, so one of it's go back to, the integral calculus stuff and just integrate it and try your conclusions that way. Right? We got a lot of different options going on here. Right? All right. Let's do this one. Not quite.
Is the P series a test?
Yep. Yeah, it's not. I'm not sure I'd say it's a test more than just a conclusion that you draw. I wouldn't say a P series is a test.
Yeah.
Now, you could just draw. If I asked you this, what does that series do? Your answer would simply be it converges. And I would just say P is greater than 1. And just be done with it. Just be done with it. That's it. Right? But again, this, right, is typically used in connection with one of these two. Right? That's typically the point of a P series. Right, a P series is really a comparison series, right? It's a series that I'm going to use, right? It's my B sub n, right? Okay, so my P series is very, very often my B sub n. It's typically when we do, and you did that on the test, right? It was no different than in the improper integrals, right? Right, you had those 3 questions on the back of improper integrals, right? And their whole purpose of the improper integrals was to figure out, what they did. We used a comparison, right, to a 1 over x cubed, right, or a 1 over x squared, or a 3 over x squared, or whatever, right? What are you looking for?
Our homework sheet.
The homework that's due for today?
Yeah, I have a lot of time to have Thank you.
Yep. All right, so I want you to work on this one, this middle one here.
And what are we trying to find?
Whether the series converges or diverges, right?